So, still working on 7.1, proving trig identities.
Are we gonna have to take another test on the phase shifts and all
This
that
week.
stuff?
We usually take a test.
Not this week, but I think I said we were doing 3 of them, didn't I?
Are we gonna have another test this week though?
Yeah.
Like that's
Oh,
the secret.
Minus? Oh, I don't like that.
Oh, what question is this on?
I think it's pretty standard.
Where's this question at?
So, it's number 26 on the worksheet. It's not one that's circled, but it's just one I want to show you. As we start to do some more complicated ones, there's definitely some thought processes or tricks that come into play a little bit. Okay? But there's a reasoning for the thought process, so I kind of want to expose you to them so you can keep that in mind when you're trying to work with them. When I first saw this one, I was stumped, okay? Because I was like, I really don't know what I need to do. There are no squares in this, you know, so there's not any Pythagorean identities right now that I could just plug stuff in and hopefully that would change things over. So I didn't know for sure where to go with it. So then this went through my head. Okay, well, I don't know which side to work with necessarily either, but let's say I was going to work with this side. How could I make this side have signs in them? Because obviously I got to show how this is equal to something with a sine theta in it. Okay? How could I make this side have sine thetas in it? Well, when you have a fraction, is there anything wrong with multiplying the top and the bottom of that fraction by the same number, or the same amount? That doesn't change that fraction's value, right? If you do something to the top and the bottom of a fraction, it will not change that fraction's value. So I thought, okay, well, if I want to have signs, if I want this to have signs in them and not get too ugly, what would be wrong with just multiplying the top and the bottom of this fraction by sine theta? And see where that goes. Okay? So it's kind of a trick a little bit. But my thought process is, how can I make this equal this? Well, let's put sine theta into this side by multiplying the top and the bottom of that fraction. Now I think you could maybe get there a different way too. I think you could change these to 1 over sines and then do common denominators and simplify from there. Okay? I think that would work as well. So if you don't recognize that trick, that could definitely be a possibility. What I just kind of thought is, well, why don't I just multiply the top and the bottom by sine theta, and I'm going to get things that basically cancel out, and it'll be a really quick step to get right here. Okay? So what I'm going to do is I'm going to take sine theta and multiply it by, now I'm going to rewrite this in terms of sine as well. So notice I changed these to 1 over sines, and then I'm going to multiply the top and the bottom of the fraction by sine. And now if you look, if I take sine theta times 1 over sine theta, what do you get? Then sine theta times negative 1. Minus sine theta, right? How about on the bottom? 1 plus sine theta, and you got it. For time purposes, I'm not going to write it out 2 more times. Yeah.
But what's the point of this? Because like you don't lose any like number.
Yeah, this is one where I don't know that either one side looks simpler than the other side.
Yeah.
So, but it's just knowing your identities and giving you different ideas to verify.
Oh,
Yeah, I just multiplied the top and the bottom of this fraction by sine theta to hopefully put some sine thetas in there. Now that I'm looking at it though, I could maybe have just worked with this too. I could have just changed these to signs. So make a common denominator, make a common denominator, and then I have a fraction divided by a fraction. If you got a fraction divided by a fraction, what do? Multiply by the reciprocal, and then that also would have given you this too. I can see that now that that one didn't pop into my head right away to do it that way, but that definitely could work. Any questions on that one? Another trick. And again, this one, they look very similar on both sides. Another trick is multiplying the top and the bottom of the fraction by a conjugate. If you recall from Algebra 2, like if I had 3 plus 5i in the denominator of my fraction, I'd multiply it by 3 minus 5i. That was the complex conjugate. We did that to get rid of the I in the denominator. Okay? The conjugate is always the same thing, but you change the sign in the middle. So like the conjugate of 1 minus cosine x would be 1 plus cosine x, or the conjugate of 1 plus cosine x would be 1 minus cosine x. Okay? So sometimes that's helpful because it'll get some squareds into your expression, and if you get some squareds into your expression, then you can start using your Pythagorean identities. So it doesn't matter which side we work with here. Let me, just for a change, let me work with the right side. Okay? I'm going to multiply the right side by 1 minus cosine x. So I'm going to take this times 1 minus cosine x, and this times 1 minus cosine x.
So you just chose the side to keep the same?
Yeah, I could have worked with the left side if I wanted to. I'm just showing you it doesn't matter which side to work with. And you could definitely do this the same. Right? Now on the top here, okay, on the top, I'm going to FOIL. Okay? So 1 minus cosine x plus cosine x minus cosine squared. So 1 minus cosine squared. Everybody see that? 1 minus cosine plus cosine minus cosine squared. I'm not going to do anything with that quite yet. I'm not going to distribute the bottom because if you look, don't I want the bottom to say this? Okay. What's 1 minus cosine squared x equal to? What's 1 minus cosine squared? Sine squared. What happens? One signs cancel. This one of these signs would cancel with that one, so you'd be left with sine x over 1 minus cosine x because cancel and cancel right there. Okay? Please look at the calendar for the assignment. I'll put it up here though. Page 434, 5 through 7, 13 to 19 odd. Okay? I don't know if it is, but I can get it on there.